In this video, we will see how do we find the various operation on matrices by using Matlab. So when you look at for the Matlab, you will find it over here, Matlab R 2019. So you may have another version as well. So this is the icon of the Matlab. Okay, when you open Matlab, you will see this page. By default, this page will come. Okay, so it is having three spaces. First is showing the current folder, another is showing the workspace, and the main thing is here command window. Now whatever operations we are going to perform, we will be performing on the command window. Okay, so we will be using this Matlab as a calculator. Means we are not going to do some programming kind of thing. Instead, it will be just used as a normal calculator. Okay, now as Matlab is a different software, it is having its own syntax to enter the details. Okay, so first of all, we should know that how do we enter a matrix in the Matlab. Okay, so let us see if we have matrix A and we want to enter this matrix, how do we enter? Now in Matlab, we are going to use the same name as of this matrix. Like if it is a capital A, we will use here also the capital A as the name of the matrix, and then we have to press equal, then square bracket, because for matrix we denote it in a, we always keep the matrix in a square bracket. Okay, now when we enter it in the Matlab, we have to enter it by row wise. As this matrix A is a 2 by 2 matrix, it is having two rows. First row is 2, 4 and second row is 1, 5. So we will enter it row wise. So start with it. First row 2 and second element is 4. So you have to put a space, one space in between and type 4. Okay, then semicolon. This is semicolon. Okay, not colon. It is dot with comma. Semicolon. Then enter the second row. 1 space 5. Suppose if you don't put 5 space, then it will consider this element as 15, not 1. So it is important to put the space in between the two elements of a row. Okay, now this completes the matrix A. You just press enter. So see, this is the matrix A, 2, 1, 4, 5. So it appears exactly same. Similarly, if you have to enter matrix B, type B equal. Now we will be entering again row wise. So first enter the first row. 1 space 2 space 5. 3 elements in one row. Semicolon. -1 space 3 space 4. Second row. Then the third row, which is 4, 8, 9. So it is optional. After semicolon, if you want to put a space, it's fine. If you don't put, then also it is fine. It's not going to affect anything. The only important thing is there should be a space in between the two elements. So this is matrix B. So you can check from here whether this matrix is appearing correct or not. Similarly, now C is not a square matrix. So again you will enter C in the same way, row wise. First row, which is 2, 3 and 4, 2 space 3 space 4, semicolon, 5 space -1 space 0. Close the bracket and then press enter. You got the matrix D. Then you will get the matrix D. It is having 3 rows. So first row is 2 minus 4, semicolon, 5 space 9. Then next row is 10 space 12. Close the bracket, enter. So this is how you enter the matrices. Now we need to perform some operations on matrices. Like what we studied about determinant of a matrix. Okay, determinant of a matrix. So how do we find determinant of a matrix? Determinant of a matrix is an inbuilt function in the Matlab. So there is a command det. So if you type det inside the bracket, name the matrix of which you are looking for the determinant. That will give you determinant of the matrix. Now we know that determinant of a square matrix is only possible. We cannot find determinant of a non-singular, non-square matrix. So here we can say that matrix A and matrix B are only square matrices. So we will find determinant of them one by one. So like if I want to find determinant of matrix A, I'll simply type determ det and matrix A. It will give you the determinant. And the same way I can type det. See, now Matlab is case sensitive. If you use capital det instead of small, you will get an error. It says undefined function or variable det, because in Matlab det means the function. So you should type the small determinant of b. So here it provided you with the suggestion, okay, but you should not do this mistake. Okay, so the moment you type determinant of b, you will get minus 55. Now we know that matrix C and matrix D are not a square matrices, so their determinant is not possible. So we will not go for that. Let us suppose, if suppose by mistake you typed it, what message you get? See, it also shows you the message that matrix must be a square. Okay, so that is the requirement of the square for the determinant. Similarly, if you want to find the transpose of a matrix, so you simply type A and hyphen, not hyphen, sorry, A dash for the transpose. That will give you transpose of the matrix A. So see, our matrix was 2, 4, 1, 5. If we take the transpose, so what will happen for the transpose? It changes the rows into columns. So first row, which is 2, 4, become first column, which is correct, 2, 4. And second row becomes second column. So this is how you find the transpose. Similarly, if I want to find transpose of C, it will give you this. So C was originally a 2 by 3 matrix. The transpose become 3 by 2 matrix. Okay. So you need to memorize this command, like what is the command for transpose, what is the command for determinant. Okay. Now let's move to some other operations related to matrices, like how do we add two matrices. So up to this matrix A, B, C, D, none of the two matrices are of same dimension, so we cannot add or subtract them. So we should have any two matrices of same dimension to perform the addition and subtraction. So let us consider this matrix E. So as the dimension of matrix D and E is same, so we can easily add them. Okay. So let me first enter the matrix E. We already entered matrix D, so we don't need to enter it again. Okay, because the system will keep stored that value. Okay, so let me enter matrix E again row wise. Minus 2, 5, 15, 7, 0, 12. Enter. So this gives you matrix E. So now we know that we can add two matrices D and E. So to add it, simply D plus E. Finish. To subtract them, D minus E. Done. Okay, as simple as that. Now for multiplication, we have to again remember the basic property when we can multiply two matrices. So we can multiply two matrices if the number of columns in first matrix matches the number of rows in the second matrix. So C is a matrix. So C, the dimension of matrix C is 2 by 3 and dimension of matrix D is 3 by 2. So it is possible to multiply the matrix C and D because the number of columns in matrix C is same as the number of rows in the matrix D. Okay. So how do we do that? We had already entered matrix C and D. For multiplication, we simply use asterisk. C star, you also know it as star, but it is asterisk. So see, resulting matrix is a matrix of order 2 by 2, which is clear from here. it is matrix CD, it will be of order 2 by 2. Similarly, we can multiply matrix D and C as well. So for that, we simply write here D star C. That gives you a matrix of order 3 by 3. So if a multiplication is possible, you can simply write the multiplication sign in between the two matrices and go ahead with the multiplication. Now in matrices, we already studied about scalar multiplication. Like if I want to multiply a number with this matrix, like this is matrix D, I want to know what will be 3 times D. So I simply write 3 multiply the asterisk sign D, enter. That gives me the matrix 3 times D. Okay, this is how it works. And then we talk about inverse of a matrix. So inverse of a matrix, again it should be, matrix should be a square. So here we saw that matrix B and matrix A both are square matrices, so we can find their inverses. So suppose if I want to find inverse of matrix A, I have to write A inverse, means the power of the matrix is minus 1. So A apostrophe minus 1. Apostrophe is nothing but shift 6. This directly gives you A inverse. So see, by using software, you don't need to find the determinant of the matrix of cofactors or adjoint. Simply put the command and you get your answer. Be the matrix of any order. Similarly, for B inverse, you can find it like this. Okay. So these are some basic operation of matrices that you can work with. It is also possible to mix two commands. Like we know that the matrix C and matrix D, the dimension are different, so we cannot add them. But if we find the transpose of matrix C, the dimension of C, that matrix, the C transpose and D will become same. So we can add those two matrices. So how we can do it in a single command? C, we find the transpose plus D. So two commands, two operations in a single command. Similarly, if I find the transpose of matrix E, it will be the same, dimension of the matrix will be same as that of matrix C. So I can add them, subtract them, or do any other operation with them. So for that, what I can do, E transpose, and suppose I want to subtract it from D or subtract it from C, so I will simply write C. It is also possible to write 2 multiply, say E transpose minus 5 multiplied by matrix C. So what happened here? It multiplied. First transpose of matrix E is obtained, then get multiplied with 2, then 5 multiplied with matrix C, and then the subtraction was done. So if you are doing it manually, you have to do it in steps. But here with the help of Matlab, you can do entire operation in just a single step. Okay. So this is how you can work with different operators of matrices by using Matlab.